Welcome to Unit 4, Measuring Prisms and Cylinders. In this unit, we will make connections between the area of two-dimensional shapes and the surface area of 3D objects, and we will explore the amount of space enclosed within these objects to determine volume. In this lesson, we will focus on naming prisms and pyramids. So let's begin. 3D shapes have three dimensions: length, width, and height, whereas two-dimensional objects have only a length and width. Cubes, prisms, and pyramids are common 3D objects that can also be referred to as polyhedrons. A polyhedron is a three-dimensional object with three key properties: flat polygonal faces, straight edges, and sharp corners or vertices. While a cylinder is a 3D object, it does not have these properties and is therefore not a polyhedron. What is a net? Imagine a package arrives at your door in a cardboard box. Before the box is assembled, a machine has to cut the cardboard into a specific pattern with specific dimensions. This becomes the net. It is the two-dimensional shape or pattern that folds to form a 3D object. In this situation, the net is folded to form the cardboard box. Nets are useful because they provide a total view of all sides of the object at one time, which allows us to gain a better understanding of the object and its properties. A prism has two congruent or identical bases that are parallel to each other, while the remaining sides are all rectangles. When the rectangular sides are perpendicular to the bases, which means a 90-degree angle is formed, the prism is called a right prism. Prisms are named according to their base shape. For example, in this object we can see that we have two congruent rectangular bases. The rest of the sides are all rectangles as well, which means this 3D object is a rectangular prism. This object has two parallel hexagonal sides, and the remaining six sides are rectangles. Therefore, this 3D object is called a hexagonal prism, or a right hexagonal prism, since the rectangular sides are perpendicular to the hexagonal bases. This last object has two congruent triangular sides that are parallel, and the three remaining sides are rectangles, so this figure is called a triangular or right triangular prism. The base of a figure is typically thought of as the bottom of the figure or the side the object sits on. However, bases are not always located on the bottom side. Imagine slicing through a loaf of bread. Every time a cut is made, a slice of the same size appears. Therefore, the end of the loaf would be considered the base because the base has the same size and shape of each slice. This object is a triangular prism because it has two congruent triangular bases. The remaining three sides are rectangles. When I slice this object, the triangular base will repeat across the object, so we can clearly see that the base is a triangle. If I was to slice a triangular prism in the opposite direction, the slices wouldn't be identical. This object is a hexagonal prism because it has two congruent hexagonal bases. When I slice this object, we can clearly see that the hexagon repeats across the length of the object. The base can be identified as the shape that repeats when the object is sliced. So therefore, the second object is a hexagonal prism because the hexagon repeats each time another slice is made. A pyramid has one polygonal base. The remaining faces are all triangular and meet at a point above the base called the apex. Pyramids are also named for the shape of their base. The base of this object is a pentagon. Because the remaining sides are all triangular, this object would be a pentagonal pyramid. This object is a triangular pyramid since it has a triangular base and the three remaining sides are all triangles. This last object is a square pyramid because it has a square base and the four remaining sides are triangles. Please proceed to the next video for this lesson.